All right, besides the charge, polarizability play a big role to determine a strong or weak nucleophile. All right, so I talked about polarizability before, but just a little bit of it. If you don't remember it, don't worry about it. Let's talk into the detail right here. All right, so here's the definition of polarizability. I'll show you as in the animation. All right. So hydrogen atom, of course, it got electrons around it, right, circling around. Let's say if there's a influence, external influence, for example, a negative charge nearby, come closer. You should be able to guess that this negative charge and the negative charge or the electron in the hydrogen will repel, right? And you will migrate to the other side to avoid that negative charge outside. At this point, hydrogen have a little electron density on one side than the other. So it becomes kind of polar, right? Become a little polar. So we call polarizability. So this is a polarizability of hydrogen atoms. Okay. All right. One more time. So oxygen, which is bigger, more electrons in it. Let's say if there's a negative charge outside getting closer to oxygen, of course, it will influence the electron in the oxygen atom to migrate to the other side. So one side gonna become partial negative, the other side gonna become partial positive. So oxygen become a little bit polar. So this is a polarizability of oxygen. Right? But if you compare the electron density of oxygen, of polarized oxygen versus polarized hydrogen, oxygen gonna have much more charge on here because there are more electrons on the oxygen. Right? Now, bromine and iodine, same thing. If there's a negatively charged particle outside getting closer, it will influence the electrons on bromine or iodine to migrate to the other side. But this time, bromine and iodine are much bigger than oxygen and hydrogen, right? And it got much more electrons. The other side going to become much more polar than the oxygen and the hydrogen, much more partially negative than the oxygen and hydrogen could do. These are the polarizability of iodine and bromine. Bromine, which is much higher than the polarizability of oxygen and hydrogen. Okay. All right. The definition, polarizability is the ability of an atom to distribute its electron density unevenly. So go on one side, right? Migrate to one side in response of external influences. So the bigger the molecules, the more electrons, the higher polarizability. Okay, so iodine is really polarizable. Bromine is really polarizable. Oxygen and hydrogen have lower polarizability, less polarizable. All right, and guess what? So, oh, by the way, go back here. So, if an atom is highly polarizable, this is your nucleophile. This is a strong nucleophile right here because of big negative charge. Electron density. That's what the nucleophile is all about. High electron density, good or strong nucleophile. Now, who's a good or strong nucleophile? Who's highly polarizable? Anything from third period down, third, fourth, and fifth, they are already strong nucleophile without a charge, even without a negative charge. Okay, because they are highly polarizable. On period second period, this guy are small, not highly polarizable. So if they want to become a strong nucleophile, they're gonna need the negative charge. Okay, so big atoms down here, they are strong nucleophiles even without a charge. The charges make them even better, like iodide, bromide, chloride, sulfur without a charge, phosphorus without a charge. They're already a strong nucleophile. Okay, but if they have the charge, even better. All right. Second period, not big enough to be polarizable, so they need a charge to help you become a strong nucleophile. The first period, the smallest one, hydrogen hydride, never ever be a nucleophile. They are too small. They are not polarizable. Okay. All right. So down here, we haven't talked about down here yet. So hydride go to weak nucleophile. Sulfide, that's two sulfide. Even though they don't have a charge, the negative charge, but they are big enough to become polarizable, so they are considered a strong nucleophile. Not as strong as a charged one, negatively charged one, but they are considered strong, better than this guy. All right. Okay, so strong nucleophile, charge, you say negative charge, high electron density, or highly polarizable atom, like big atom, third period, fourth period, fifth period, anything down. down below. All right. So again, hydride is too small. First period, never ever be a nucleophile. Never attack that. But sulfide, it is a strong nucleophile, even without a charge. Okay. All right. So concept test real quick. So what are two factors that influence nucleophilicity? What makes a nucleophile strong? Negative charge and size, basically, or polarizability, or size. You can enter size too. Size and polarizability goes hand in hand. They go together. All right. Okay. Let's do this together on the next video.